Today I'm going to take a modal driving point survey. I can do that using Test Lab impact testing, and this final step of the impact setup worksheet is called driving points, and this is sort of a nice place to take a driving point survey of your structure and figure out where the best place is to impact your structure and get some good data. So today I'm going to be operating on this plate that I use in the article. We're going to take some driving points on this structure in the software here and go through the process. So the first thing I need to do is on this right hand side I set up essentially my input point, or whatever I want to call the driving point. In this case I've got a total of 15 points laid out on this plate. I'm only going to test a couple of them today. And so this point that I'm starting at is point 8, and so I'm going to call that the name of my FRF, or my driving point FRF. And then response channel is just the channel on my front end that my accelerometer, this guy, is plugged into. And then I say I want to take 3 averages, and then I hit start. And so the software tells me it's ready for a measurement, and now I'm going to take my impact hammer and hit right where I have the accelerometer. Now I don't want to hit on the accelerometer, and I don't want to make any contact with the accelerometer, but I want to hit as close to the accelerometer location as possible, and so I'll do that here. Okay, so I get my 3 averages, and I see this is sort of the instantaneous FRF that will change up or update every time I make an impact, and this is the average, or the sort of the summed average of all 3 points that I took. So you see I have my driving point FRF here, 0.8 for the force input location and 0.8 for my response location. That's the definition of a driving point, where I'm making both the impact and the response measurement at the same point on my structure. So next I will try a new point, and so I'm going to change this from 0.8 to 0.4, which is be my next impact location. So I move my accelerometer to 0.4, I hit start, and now I'll impact my structure at 0.4 also. Okay, so now you see I have a second FRF here, and just for comparison I'm going to do one more. I'm going to do 0.1 right up over here in the corner. And so I'll put my Excel on there like that, and now I'm going to do 0.1 and hit start. Okay, so now I have 3 driving point FRFs. If I want to compare them, they all kind of look similar when I'm just taking the data. I see a bunch of good, nice, clean curves there. But the point of a driving point survey is to see which one of those impact locations best excites the modes I'm interested in. So if I select all 3 of these and hit display, you see all 3 FRFs in this window here, and you can immediately see that certain peaks aren't excited by certain impact locations. The blue curve here is missing a bunch of peaks that the red and the green curve have. I can do the same comparison in Navigator. So if I come over here, in my section, in my project, I will see a folder called driving points, and my 3 FRFs that I just acquired will be in here. I create a front back, select these 3, and drop them in. If I zoom in, let's say I'm interested in the first 8 peaks or so. I'm going to zoom in to about this area here. And I can look at these 3 FRFs, and I notice right away that the 3 FRFs don't all have the same amount of information in terms of peaks in them. So if I put an X cursor on here, you see blue really only has a peak here, here, and here. 3 peaks, where if I look at the red one from 0.1, I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 peaks in my red FRF, only 3 in my blue. And then I have 1, 2, 3, 4, 5, 6 in my green. So green is better than blue, but really my red point here on the corner has the most data, or excited the most modes by impacting that. And that has to do with nodal lines for this structure. And if you notice on the structure 0.8, this is right at the center point, right? So we have a center line in both directions, and I'm exciting right here. It's going to be on this nodal line as well as on this nodal line. So as this plate starts to bend like this or bend like this point won't participate in either one of those modes. And so by impacting my structure here, I'm not going to very well excite that mode either. Same kind of thing for 0.4, where I have a center line here for maybe my first bending. Maybe it bends here and on the other side. Obviously, there are some modes where this 0.4 is not participating. But if I look at 0.1 out here on the corner, it's not on any center line. It's kind of way out at an extreme edge of the structure. And so this is going to be participating in almost all of the modes for this structure, and that's why I see more peaks in the red FRF than I do in any of the other FRFs. And so I notice there are fewer peaks. You can actually hear this difference. I'm going to strike the plate and the blue location, 0.8, and just listen to the tone that the plate makes. You're really only hearing these three frequencies. You're hearing more that I haven't zoomed in on here, but you can hear there's different spectral content here than even 0.4, and you start to hear some dissonance or some, it's not quite as musical sounding. It's because I'm exciting more frequencies that may not be so well aligned. And it gets even more extreme if I go out here to the corner. Now I'm hearing all of these frequencies that are being excited. So you can actually tell kind of as you hit a structure like this that makes an audible tone, you can actually hear the difference in the frequencies you're exciting before you even look at the data. So that's a little bit about a driving point survey. Hope you found this video interesting, and thanks for watching.